Good day. This is Dr. Ted Loder for Conversations with Dr. Greer on the World Puja Network. And I'm your host today. We want to thank the World Puja Network for sponsoring these conversations with Dr. Greer. And here we go. Today's, I'm the host. Today's guest will be Moray King. And let me introduce him a little bit. He's an engineer, a scientist, a writer. He's written several books on energy theories. He's a student of energy theory and technologies, which makes him stand out in the crowd of energy inventors who are working with new energy technologies, because he really is trying to figure out what is actually going on from the physics engineering point of view. He's, as I said, he'll talk about his books in a minute. He's been a speaker at many Tesla Tech conferences. And with that introduction, welcome, Moray.
Well, thank you very much, Ted.
What I'd like to do is, if you could describe, maybe right now might be a good time to start, describe a couple books you've written, where you can get a hold of them, just so people are aware that you've actually done something in this field. And then we'll go on talking about water, fuel, the future, theories, and other things.
Okay. I really never did start out to write books or anything on this topic. In fact, I was a normal graduate student. I was started as an electrical engineer back at the University of Pennsylvania, and then I was in the master's program in systems engineering. Then I think it was about 1974 when we had the oil embargo, and at that point, coincidentally, while all the cars were lined up at the gas station, I had a roommate that was a physics major, and he was really into general relativity. And he showed me inside of the big book, Gravitation, by Meisner, Thorne, and Wheeler, the last two chapters of the book talked about zero-point energy.
Interesting.
And I never heard of it.
Of course.
And here I was in graduate school of engineering, and I I got interested. I asked the obvious question, gee, is this energy really there? And if so, can it become an energy source? So I interacted with my professors in the engineering school, and not one heard of it, not one professor.
Wow.
However, when I went to the physics department, then I could start talking to physicists who had heard about it. And even there, they don't even teach it to undergraduate physics. It starts to be mentioned a little bit in the textbooks of quantum mechanics, especially quantum electrodynamics. But before you even hear of this energy, you need to be a graduate student in physics.
Wow, and that eliminates a good percentage of the physics majors.
And perhaps most importantly, it eliminates the engineers who are the practical guys who roll up their sleeves and do things, and they do them as a team. The engineers are probably the most effective as a group about accomplishing big projects. So we have inventors on one side who stumbled across effects on what they were doing in their inventions, and many times creating energy anomalies and every now and then claiming free energy machines that sound blatantly impossible. Here I am saying, wow, what's this with the zero-point energy? So at this point, I start reading the physics literature, and I have to go to the journals, the Physical Review and things like that, and I begin to build a case. I'm always pursuing the question, is the energy really exist? And if so, can it actually be tapped as an energy source? And it was a result of these investigations that caused me to give talk, and every talk had papers typically associated with it as I got invited to conferences. And my books ended up becoming a collection of these papers because invariably, especially early on when there's very little information on this, people were just begging for Xerox copies of the papers and things like that. So then in 1989, when the cold fusion was announced by Pons and Fleischmann out here in Utah, I went ahead and grabbed that group of papers from pretty well from the time I started and gathered them into a book.
Mm-hmm.
And then is that book the Tapping the Zero Point Energy? Correct.
That is correct. I have an original first printing, early on copy.
Yeah, those were actually rare. They're collector's items now because
the white cover ones.
Yeah, the beige cover.
Yep.
Because as I pursued publishers to see if they were interested in publishing it, I got caught in what they call you're caught in the middle. Your book is a little too technical for the layman, and yet it's out of the paradigm of science. So the publishers were saying they don't see it being a major seller because either direction or as a small market. So I ended up actually finding a printer up in Salt Lake and printing and publishing it myself.
Wow.
And what happened was Adventures Unlimited, Adventures Unlimited Press, were kind of experts in distributing esoteric books worldwide. Mm-hmm. So I asked them, hey, would you guys be interested in just, fronting these books and selling them? And they were. And they were surprised. It sold very well.
Good.
At that point, and so at that point, when it came time to gather up the next group of papers, this was in 2001, they were very eager to publish it. Mm-hmm. And so from then on, they became the publisher of the book. So the second book is called Quest for Zero Point Energy. Mm-hmm. And then eventually, I think it was in 2005, it came out with my third book, which was The Energy Machine of T. Henry Moray. Right. And the last name was quite a bit of synchronicity for me because this inventor who lived in Utah, his last name is spelled identically to my first name. It was the first time I've encountered that name synchronicity in my life. And I felt I was destined to write that third book. And the third book was basically a presentation. I gave the slideshow, I think, originally in 2003 back at the Conference on Future Energy in Washington. Mm-hmm. And I was constantly being clamored for copies of the slides. So what I thought I'd do is just annotate my slides there. That book was a picture book, basically that presentation. And in the second half of the book, excuse me, were all the references that I gathered up for my research, which are hard. They're a bit esoteric because they're not from the web. It was before the web occurred, and these were literally from the libraries, the standard libraries in physics, where I could dig up the support that I needed to build the case for tapping the zero-point energy.
That is, that's a wonderful story how it's evolved, and I've enjoyed your name your name coincidence there. Would you explain for our listeners, many of whom have heard Dr. Greer and myself and others speak about 0 point? What's your simple definition of 0 point energy that somebody in the elevator might be able to understand? How do you view it in a sort of an English word sort of terminology?
Well, the phrase 0 point refers to absolute 0 degrees Kelvin, meaning what is the nature of the fabric of completely empty space? No light, no heat, no matter. Is it a void, or is there something going on in this fabric of space? Well, it turns out there's something going on. It's fluctuations of electromagnetic field energy at a very, very tiny scale. In fact, 20 orders of magnitude below the size of the elementary particles. Think of it as microscopic lightning. And down at what's called the Planck length, and it's on the order of 10 to the minus 33rd centimeters. And so you have this blinking of energy inherent to the fabric of space. It's natural to ask the question, gee, where did it come from? How did they know it's not a propagation. It's just inherent to the fabric of space itself. They said, it's the source of the Heisenberg uncertainty principle. It's an underlying jitter that occurs in all systems, and it's the foundation of quantum mechanics, this underlying jitter.
I like that term, underlying jitter. That sort of is a nice description, or you can kind of feel what you're saying there. Go ahead.
Right. So the question arises, I said, well, can this underlying jitter possibly be tapped as an energy source? Well, the answer was quick in coming as I went to the physics professor. They said, absolutely not, because the jitter is chaotic. It's random. and random things must forever remain random. That's the second law of entropy. But coincidentally, in 1977, just as I was getting started with the interaction with the physicist, Ilya Prigogine wins the Nobel Prize in chemistry for his systems work and systems theory work that says under certain conditions, a system may evolve from chaos to self-organization. And these conditions, it turns out, can be fulfilled by certain theories of the zero-point energy, certain particular models. In particular, the model was Wheeler's geometric dynamics, the very model that got me started in the first place. And these conditions are the system must be nonlinear, far from equilibrium, and have an energy flux or matter flux through it. Mm-hmm. And it turns out that Wheeler's theory can fulfill these conditions under certain circumstances. Mm-hmm. And these circumstances are that the system must be, you must work with a nonlinear system like a plasma. It must be driven far from equilibrium, like an abrupt discharge, electrical discharge in a plasma. And furthermore, number 3, there must be a flux through it. And it turns out that the energy flux of geometric dynamics is essentially a flux from a higher dimensional space that passes through our three-dimensional brain or our three-dimensional space. They call it brain theory now in string theory, and they recognize this to exist. Back when I started, they thought I was a kook when I suggested that this existed, but I was just really quoting Wheeler's work.
Sure.
And therefore, it offers the opportunity for self-organization. Moreover, they were modeling this type of self-organization when they talk about virtual pair of electron-positron pairs popping into existence in the vacuum fluctuations and then going out of existence. And so when we talk about something to organize into a pair of particles, this is a tremendous self-organization event because that particle is huge compared to the individual vacuum fluctuations. And therefore, we have an example in the actual theories of quantum electrodynamics where there is a constant self-organization event constantly occurring in the vacuum itself. And interestingly enough, when the physicists object to this and say, oh, that's just imaginary, that's just theory and everything else, at which point I say back to them, I said, well, if it's just nonsense, why don't you remove it from your models? Because why don't you use Occam's razor? Why do you have such a complex substrate with all this activity if you say it's not existent? You can do better than that. Just say it doesn't exist. But they can't because they can't make quantum electrodynamics be accurate without that model. So essentially, in their own modeling, they're saying this type of self-organization is occurring. The thing where they really have trouble with, that it could actually occur on a larger scale than just the elementary particles, but it could occur with an interaction between plasmas and the zero-point energy where you could activate, cohere, and have that coupled into a collective of the plasma in a self-organized fashion that's recognized to exist, called a plasmoid, which is basically a torus form, a vortex ring of plasma that has anomalies, experimental anomalies of excess energy and excess force associated with these forms, these plasmoid forms. So therefore, I was not only building my case theoretically that it might be possible to do, I said, here is experimental evidence of it actually occurring. And we can see while we study the anomalies of these plasmoid forms, that this gives us a clue. And invariably, in many of these devices that exhibit excess energy or excess force or any of these events, invariably in the heart of that system are these torus plasmoid forms coming into existence, perhaps for a very short time, but nonetheless, once they exist, they now manifest and the excess energy. They kind of pump it into our three-dimensional space, so to speak, this orthogonal flux.
Well, that's wonderful. I think we might be jumping ahead of the story here in some sense because we're going to the sort of the mechanisms without thinking about what people have gone through, both you and many others over the last many decades, about observing, in particular, water, using water to run as a fuel and what have you. And that's a whole story in itself. And I thought I might start there with a couple of questions, and we'll build up to the theoretical stuff so we can return to the plasmoids, toroids, cavitation issue. One of the pioneers, if you will, in the whole field of water to fuel or using water as a fuel through some mechanism was Stan Meyer. And he had a number of examples of technologies. I assume you've read his work quite extensively at some point. And any sense of what he was doing?
I had a number of interactions with Stan Meyer.
Oh, good.
He came to my workshop conference in the early 90s, the Denver conference on zero-point energy. I wrote Stan. I says, you realize where your energy's coming from. It's really not coming from the water. It's coming. He called it a universal field. Yes. By the way, I might add a footnote regarding Stan Myers. He had a twin brother, Stephen.
Oh, I know. Yes, I've spoken with Stephen.
Yeah, no information is lost whatsoever of that project. Steve Myers was the brains behind the project. He was the electrical engineer.
I know that.
Dan was kind of the salesman and the speaker, but Steve was really the guy doing the work. And so what's great is if Steve would love to participate, he could glorify his brother, who was assassinated. We know about that story.
Yes.
And basically, I don't believe they realized exactly what the effect was. That it was a zero-point energy effect. Water was not the fuel. Water was simply the medium for which we made these forms, these torus forms, coincidentally. And then when they get abrupt discharge in the cylinder itself of the internal combustion engine, that's when they turn into plasmoids. They're approximately these water clusters are approximately a micron, perhaps less, because it manifests the gas. It's essentially the second component of Brown's gas. And then when these get ignited, they become plasmoids. And plasmoids, there's lots of evidence that these abrupt discharges in water, especially if we have this form pre-made, exhibit both anomalous force, anomalous acceleration, which is part of the anomalous force, and anomalous energy, of course, which makes the piston move. We're not just doing the simplistic, let's make some hydrogen, let's put the hydrogen in the cylinder, let's burn the hydrogen, heat up the air, and move the piston. That's traditional internal combustion. Sure. Highly, highly inefficient. Perhaps these things are about 20% efficient because we're wasting most of that chemical energy as heat. Yeah.
Exactly.
All we did was heat some air and move a piston. With these clusters, we're milking a second anomaly that's not well recognized at all, is that when you make these torus forms of plasmoid, they tend to self-accelerate. And thus, they tend to move the piston on their own without heating. And, of course, in these water experiments, because there is some residual hydrogen, most of all of these subtleties are being completely lost by most of the investigators.
Right, because the gas produced, the hydroxy or Brown's gas, is a mixture of hydrogen, oxygen, and other stuff that you're speaking of.
Right. And, of course, nearly everyone, I'd say, across the web, and most everyone investigating this, probably with the exception of George Weissman, because he's been investigating very carefully, just simply believes it's hydrogen. Yeah. But obviously, hydrogen can never make these units, especially if one makes a genset that's just a generator, engine combination, like a Honda generator, and get that thing to self-run with an electrolyzer, and there's claims of doing this. Just idling that is an extraordinary claim because it can't be hydrogen. Not only does it cost you more energy to disassociate the water and the hydrogen than you ever get back when you burn it, but more importantly, the high inefficiency of the internal combustion engine.
Sure.
If it's only going to be 20% efficient, and all we're going to do is heat air to move the piston, we're talking about an extraordinary excess energy, 5 to 1 over the stimulation energy, right? Certainly, hydrogen can't even come close to explaining that.
I've heard people speak of this over the years, and I've personally seen a lot of Stan Meyer's equipment and things a few years ago when the Orion project was involved with it, or trying to get it. And first of all, Stan Meyer was using a pulse of voltage changes, very rapid pulses. So he was, as you said earlier, sort of knocking the system out of equilibrium to produce his hydroxy gas in this system. I always assumed, and others have too, and this is where I may be wrong, I don't know, that in doing this, it kind of shakes up the water molecules so that they break apart. It's sort of the system. The water goes into resonance with the voltage, whacking it, if you will, in a non-scientific term, so that the water kind of breaks apart. The normal energies that hold the hydrogen and oxygen together in the water molecule come apart easily. It's like somebody pushing a swing, and just a gentle push at the right moment in the swing as the child goes back and forth causes the child to swing higher and higher without apparently putting a lot of energy into it because the system is in resonance. Any comments about resonance issues in the whole process?
Oh, yes. In fact, that was my starting hypothesis when I first focused on these Brown's gas type electrolyzers as a research project. I heard a talk in 2006, and I just said, okay, I'll pick that as a topic, and I sent in my title very early. I said, disassociating water with the 0-point energy. I had the hypothesis that somehow we're activating some 0-point energy, and it's helping us to disassociate the water for less input energy. And that's what my hypothesis was, perhaps just like everybody else in the world and on the web, thinking, okay, that's what likely is happening. When I started to drill in on the research, I completely changed my mind. And I said, no.
This is why I'm asking.
Yeah, it's not that. The characteristics of the gas behave too much like these plasmoids that Ken Shoulder discovered. He called them EVs, electron volitton for strong charge, or EVOs, exotic vacuum objects. It was seeing the coincidence of the nature of this flame, this Brown's gas torch, and what it could do to the metals, completely discovery of Ken Shoulders. And therefore, I said, wow, this is quite a coincidence. Now, I had a big advantage. That Ken Shoulders was my hero for years because he has been since the 80s, and he really came public in the 90s. He investigated these micron-sized plasmoids. They're like miniature ball lightning.
Yeah, they're like little donuts for somebody sort of trying to visualize what you're saying. They're really quite amazing.
When I say plasmoids, just think of like a little donut, like a little torus. It's all lit up because it has excess energy. And Ken investigated these, and he showed because he can make them so easily, he would have a small capacitor with so much energy on it, it would launch this tiny little ball lightning entity, right? And then it would disrupt the bonding when it hit a metal or a high melting point ceramic. It would disrupt the atomic bonds, electron bonds. He said it just causes the atoms to let go of each other. The energy was stored coherently. It's not heat that's making them let go. That's why he could disrupt high melting point ceramics, probably, and the Brown's torch does the same thing. Whereas
I know the flame, if I may interrupt for the listeners here, the pictures of Ken Shoulder's work, which can be found on the web, are quite impressive because he's actually showing glass, ceramics, aluminum, and other metals where one of these things is hit. And what what you see is essentially a hole in the item and a melt zone around it, as though somebody went in there with an extremely hot, extremely small thing and just melted a hole through, and it's kind of like a splash.
Yeah, and he shows it's not heat because the residual area didn't get hot. It was just that localization where it struck. And so that anomaly completely convinced me that we were making the same thing in water from these electrolyzers. There was a secondary component that was making something similar. And I said, this is an absolute miracle because it's so simple.
Yeah.
Whereas to do the plasma work and to do the careful studies like Ken made is beyond the scope of your ordinary hobbyist or your garage guy or just somebody that wants to jump in. All of a sudden, we can produce this anomaly in the simplest fashion just using water as the medium.
So maybe you could explain at this point, you mentioned there that the Brown's gas exhibits a number of anomalies. And I just mentioned burning tungsten, yet the flame's not hot. Maybe you could describe a few more of those anomalies that say, this is not your grandmother's hydrogen and oxygen. There's something else going on, because this is really key to the understanding of what's going on. These anomalies have pointed the way. And maybe you could describe some of those for the listeners.
Yeah, certainly for me it was because the nature of these craters and everything else. Perhaps the most dramatic is the vaporization or sublimation of tungsten by a cold flame. When we say a cool flame, we're talking a flame a little bit above the boiling point of water. People can quickly pass their hand through the flame. And you compare that to the standard welding torches, which have quite high temperatures, including the hydrogen torch, which is a great comparison. And none of them can vaporize tungsten. They're just simply not hot enough. And yet the Brown's gas torch can do so, vaporize it or oxidize it. And it's only after the torch hits the metal does the interaction get hot. Because what happens, it causes the electron bonds to let go, and then as the electrons collapse back to the ground state, that's when the heat gets generated. So we convert it from a coherent storage mechanism in that torch back to heat as a result of the interaction with the metallic surface. So that was the number one huge anomaly. The other ones were just simply unbelievable. And the second anomaly was, there seems to be rumors of transmutation when the flame seems to interact, or sometimes even in the electrolyzer itself, there are claims that, there's transmutation on the plate. Now, element transmutation is considered at these low-type energies, it's like cold fusion, it's considered impossible. You're asking somehow the nucleus to change.
Right. In fact, I remember taking a nuclear chemistry course many, many years ago, and transmutation was one of the great no-nos, except for radioactive elements, of course. But under normal
or possibly a particle accelerator.
Yeah, exactly.
Right. Yeah, because now you have a single particle that you can ram into the nucleus after taking it through. That's huge.
But that's not low temperature stuff.
But to get something like that from these plasmoids, right, is just considered absolutely out of the question. And so Ken Shoulders was demonstrating it. He gave a talk, I believe, at the conference number 10 on cold fusion. He gave a slide presentation, which you can download from his website, showing he's getting nucleosynthesis, which means these plasmoid strikes, these little strikes, were creating elements all over the periodic table, not just moving one nucleus, over on the periodic table, just one atom or two. This thing was bizarre. And now you think just an ordinary transmutation is bad. This is worse as an anomaly. Nucleosynthesis means we're getting way over the top. So Ken, being a nice guy, was simply politely ignored. He was demonstrating this in his experiments. However, Ken was not alone on these experiments. The Russians, the Ukrainians, the Russians are now interested, were making large plasmoid strikes. They make big ones, about the size of a centimeter.
Wow.
And they hit very pure targets, like pure targets of copper, that they make extremely pure. And when they strike one of these, it really blows the heck out of the target. Mm-hmm. But they see nucleosynthesis in the residue. They see that all over that smashed target, they find elements all over the periodic table. And not only that, they have unusual isotopes not readily found in nature.
Uh-huh.
And they're doing the same experiment, except at a larger scale,
sure.
Producing nucleosynthesis. And the Russians are extremely interested. They have a conference every year on this topic. I think Transmutation and Ball Lightning is the title of the conference. Mm-hmm. Their professors are paid to come up with theories, try to explain this. They repeat the experiments. It is the best transmutation experimental work on our planet. Is being performed by the Russians. And Proton 21 is the name of the laboratory, and it's they have a nice little PDF booklet showing what they're doing, and anyone interested can go look it up. This work is completely ignored in Western academia. Mm. So we have perhaps the biggest anomaly occurring there.
And so, of course, that has some very important implications for the dudding of nuclear waste.
Oh, of course. If you have transmutation and it really occurs, then if you start engineering that effect, you could say, gee, if I have some nuclear waste, can I transmute it to something more benign? And
sure.
The possibility certainly exists. But first things first, we have to recognize that this anomaly that I would say way out of bounds. So if you look at how bad it is, cold fusion is bad enough. That's just making a deuterium fusion. And then if you say, transmutation, meaning the palladium or the nickel and the electrodes could switch over to something nearby, like claimed in the latest Rossi announcement, where I think he's converting nickel to copper or whatever. But to then, now you have to overcome the Coulomb barrier and all the standard arguments against it all apply. And then to say I have nucleosynthesis, that means I'm all over the periodic table. It really, really implies that our modeling of the nucleus is inadequate to explain that bizarre effect. And that's probably the number one reason it's pretty well ignored. They said that can't be. It would blow out our models. The Russians are willing to explore new models, trying to explain this, and they do.
Well, the trouble is our approach in the U.S. has been to say we can't do anything with it and bury it in Nevada or try to bury it somewhere, and wait 100,000 years or a very long time.
Oh, right. Well, see, we have to, before we can even apply engineering, right? If the engineers don't believe it's possible, nothing gets done.
Right.
We have to show by experiment there's a new effect here, and then accept the fact that it's happening. Once that's accepted by our scientific community, then it's not hard to then ask the next question, just like you did.
How do we do it?
Oh, can we apply it to a project like nuclear remediation? That step's not hard to take. The first steps are the toughest because it has to overcome the belief, the paradigm of what is possible by our scientific community. They just say it when you know something's impossible. You will not look. It's just that simple.
Right.
Right. It will be ignored. It'll be ridiculed. It simply will not be explored, and no progress will be made. That's why this entire discovery really has to come out from outside of academia, to come from the inventing community. And that's why these electrolyzers got me so excited, because I thought, now finally something simple enough then inventors can play around with this, become successful. If it spreads enough, then the students will be interested, and then the students will approach their professors, and there will be a few professors that get interested.
Right, that's the hope.
And then things gradually change. Now, it's tough on the professors because look how badly Pons and Flesch were mistreated.
Oh, my gosh, yes. still.
Nobody wants that. There's so many examples in the history of science.
I was going to just say the history of science is replete with impossibilities that are common everyday things today.
Correct. And the mistreatment of those people making those discoveries was to me, it was just an abomination. It's just horrible. Perhaps I like to point out what I think is the worst example that ever occurred in science was Boltzmann himself. Boltzmann was rejected so badly by his peers that he got very depressed and committed suicide. And what he came up with was the statistical atomic theory of thermodynamics. It was an incredible mathematical breakthrough for the foundations of thermodynamics and our science today. Mm-hmm. And he was ridiculed so badly that he ended up taking his own life. So it's a travesty. And of course, the history books are just full of examples.
Sure.
Wright brothers are a great example.
Oh, yes.
That's considered impossible, and yet they're doing it, etc.
It was considered impossible years after they were flying around the country.
Yeah, isn't that something?
Yeah.
And see how now Fleischmann passed away, but Pons will likely see the vindication of his work because there's enough replication occurring on these nuclear transmutation events.
Well, one of the problems with that kind of thing is that at least from the academic scientist point of view, and having been an academic scientist all my life, I kind of can say this hopefully without too many repercussions, is that they tend to look at things if we don't have a theory for it or don't understand it from a theoretical point of view, it can't be possible. And, so there's observational science and there's theoretical science. And hopefully you make an observation, say, this is real. Now, how does it work? As opposed to, we don't know how it works, therefore it can't be real. And there's a dynamic going on in that between those two views in a lot of academic science. And it puts things down essentially. What other anomalies do we see in this gas, this Brown's gas or hydroxy gas, and that allowed you to have clues to what's going on?
Well, perhaps the biggest occurred for me because I didn't know of this work was Mark Leclerc's work with cavitation in water. Mm-hmm. He contacted me shortly after my presentation in 2011 at the Conference on Future Energy back at Washington. He then shared his work and about anomalies that he found just from cavitating water.
Maybe you could describe what cavitation is for the audience here.
Right. When you really put water in a lot of turbulence, or especially when there's low pressure from the turbulence, a great example is the propeller.
Sure.
Right? There's low pressure builds up, and kind of in that pressure you make little tiny bubbles. They're called cavitation bubbles. They're basically bubbles of low pressure where you kind of pull the water apart. Mm-hmm. And there's a very interesting, spectacular, I would say, anomaly that Mark Leclerc discovered associated with the cavitation bubbles themselves. Mm-hmm. And what Mark was an expert in water cavitation fluid hydrodynamics. He's a engineer. He's kind of like me. He's just everything but the PhD. He doesn't quite have the degree, but he did all the coursework and studies like that. He's back in your neck of the woods. I think he's in Maine. And so he discovered that some phenomenal effect occurs and he's learned to take advantage of it. And the effect is this, that when the cavitation bubble is near a surface, it deforms into a torus. Yep. And going through the whole of the torus is called the reentrant jet. This is recognized in standard fluid mechanics. What he discovered that this reentrant jet has all the energy of the collapsing cavitation bubble get concentrated into it, and there's extreme pressures in that tiny little jet. Now, if the bubble's on the order of microns, this jet is on the order, it's with maybe on the order of a nanometer. And under these extreme pressures, water takes another state. I think it's over 300,000 psi, and water goes into a solid state form. So he's discovered a macro-ionic water crystal is what he calls it. Mm-hmm. And the tip of this crystal has a plasma-like Bow shock wave that exhibits all the characteristics of Shoulders EVs or EVOs. And I thought, my gosh, this is the same thing. And when it strikes something, it makes the craters like the EVOs. If this is what Mark discovered, rather than striking something immediately, if he had a hole there and that this jet could shoot through the hole, it would actually self-accelerate. Similar phenomena that Ken Shoulders recognized from this Bow shock wave. And then when it strikes the next target over, the next plate over, it then exhibits the transmutation in the form of super or nucleosynthesis. Supernucleosynthesis. The super means this looks like what supernovas do, the type of nucleosynthesis they do. And as he studied the nature of the material, the isotopes in the target where these craters were from being struck by these things, he found they were in multiples of the helium nucleus, the alpha particle, and that's 2 protons and 2 neutrons, and these unusual isotopes are all over the periodic table. It's basically the same discovery that Ken Shoulders made with plasmoids. All of a sudden, Mark LeClair showed how he can do it with water, cavitating water.
In a simplistic view, what you're saying, what the observer, the naive observer, might observe, is just pitting, a sort of a scraping, a pitting of the propeller or the device that's producing this cavitation. But what you're saying is what's actually happening at that microscopic scale is this whole process you just described.
Right. Now, in order to get the actual transmutation, you have to get that reentrant jet to go through a hole.
Okay.
It can't. If it strikes too early, which is very typical in the propellers, it just does your crater damage that you typically see.
Okay. So that hitting process.
Right. But if it should go through a hole, that water crystal undergoes the self-acceleration phenomena and builds up energy. And then when it strikes something at the far side, another target, that's when the transmutation occurs. This was Mark's spectacular discovery that water cavitation under these particular circumstances could actually cause nucleosynthesis. This is so way over the top, it's unbelievable. So we have, basically, it's the third experiment of doing nucleosynthesis. We talked about Ken Shoulders EVs. We talked about the Ukrainians with the Proton 21 laboratory. And now we have Mark LeClair, whose website is nanospireinc.com, sharing information on this discovery because he seeks replication. He desperately needs an ally in the standard physics or chemistry or any professor willing to repeat the experiment.
Right.
And boy, I tell you, that's a tough fellow to find because they basically are, it's too crazy. They'd be scared off by this paradigm change and think of the ridicule that would fall on their head.
Well, part of the problem with academic science, having, again, been in that field for all my academic career, is that experiments and proposals that you put together need to be funded so you can get promotions and all the rest of that sort of thing. And in order to get something funded, you have to propose something that your peers agree with or think is a good idea. And if you're too far out on a limb with your peers who review proposals and recommend or turn down proposals, you never get these outside-the-box things done. And since all these experiments for an academic person who's pulled in multiple directions, they try to go with something safe or something gets funded because that's sort of the name of the game. It's sort of in some ways, the whole field is almost self-defeating in terms of new discoveries. In fact, the discoveries should be incremental, not giant steps for mankind sort of discoveries, which is what we're talking about here.
Probably this is the case throughout history. A great book, Thomas Kuhn's The Structure of Scientific Revolutions. Same thing. It's completely rejected by the academic community at the time. It really takes a whole other team doing the experiment and believing in the new paradigm. The old team refuses to even look at those experiments. They just agree it's nonsense, and therefore it won't look. And typically what happens, the way the world changes, is they die out.
Right.
And the new generation picks up on the new paradigm. And that was the point Thomas Kuhn made in the book. So it's human nature that's really blocking the discovery.
So back to this gas, this magic gas here, how is the excess energy stored within the hydroxy gas so it doesn't self-destruct? I mean, I've read and seen the experiments where people have produced the hydroxy gas and actually stored it in tanks for a period of time, yet it's still, when they, quote, burn it, torch it, whatever else, it still exhibits some of these properties. So whatever form has been created appears to be at least somewhat stable. Any thoughts?
Yeah. In fact, this is a very good point. In the first place, be sure if you're going to store it, we're looking for the secondary gas, which is heavier than air. It's not hydrogen. Your storage should be permeable to hydrogen. We should let the hydrogen vent away, so you're not storing hydrogen with oxygen. That's a very dangerous thing to do. So you have to be pretty sure that you're making very little hydrogen and you're letting it vent away from your storage mechanism. Mm-hmm. And others have done this, and you'll see that in the slide presentation, like Omasa and things like that. They're using cavitation. But this takes us full circle. What happens in this cavitation reentrant jet? What Mark LeClaire has discovered, that they can form into rings. They go, the head is positive, it can close on its tail, which is negative. Large rings are unstable, and they tend to break apart. But small rings, on the order of a half a micron, can be stable and long-term, and that's what I believe is the storage mechanism. Basically, it's a linear water-type chain of OH ions just closing into a ring. That type of thing, the Mark has measured enough on the structure of this water crystal to show that the axis has linear water isomer in it. The electrons of such a form tend to be stored in a high energy state up in the d orbitals. Mm-hmm. And when you have a coherent cluster where the electrons are held in this high energy state, it's called Rydberg matter. It's like a cold plasma. And all of a sudden, it's something that could actually be stable.
Right. So that's in the gaseous form.
Yeah, it can be, or it can be in the liquid form too. But it'll tend to bubble out because when it's small like that, on the order of half a micron, Brownian motion tends to drive it out, make it put it into a gas. But it's not hydrogen; it's heavier than hydrogen. Thus, for a chemistry department, you can put a filter in and vent away your hydrogen and study this residual gas that's heavier than air. And that's
because the hydrogen molecules are dang small.
Right. They
relatively speaking.
Yeah, even an inflated balloon doesn't hold hydrogen very well.
Right.
You could put your gas in a balloon, let it sit overnight. It'll vent away most of the hydrogen, leave you a small residue. That's heavy, and it stays there. And even though there's one other point that might be extremely valid, that even though this little ring is in a higher energy state, that when you ignite it with an abrupt high voltage pulse, you convert it straight into a plasmoid. And in the plasmoid state, it immediately starts pumping in more energy into the system, creating anomalous force. It starts to self-accelerate. Thus, taking that into a plasmoid immediately starts injecting new energy into the system, and the self-acceleration tends to move the piston in the internal combustion engine, and it creates the anomalous force effect that moves the piston without just heating air like you would do when you burn fuel. You're moving it from this anomaly, very much like the PAP engine that works with inert gas clusters that get ignited to a plasmoid form, exhibit the self-acceleration anomalous force, and they move the piston. And from a scientific perspective, this too is impossible, but it's a great example to study, because clearly there's no combustion happening in inert gas.
Right, because it's contained within the cylinder, and it just then collapses and restarts.
Right. we're milking a big anomaly. It's called anomalous force. Ken Shoulders likes to call it propulsion, this word that these plasmoids, once you excite them into this torus plasma state, they exhibit anomalous acceleration, they exhibit anomalous force, and thus the internal combustion engine is actually an advantage. It's a device, instead of just being a pure low-efficiency loss, it becomes a device to extract this anomaly. We move the piston.
Is that what I got a couple of questions for you on that in terms of the experimental world, where people have claimed to be running the generator, producing enough power to produce enough gas, to produce enough power, et cetera, et cetera. In other words, looping the system. To me, the only true way to demonstrate that one actually has nailed the over-unity concept or the over-unity, the engineering, is to loop a system with excess energy available to do work. That's my own little prejudice on these things.
Absolutely.
So you've noted in your slide talk there are several groups that have done this, including a gentleman running a motorcycle on water and some magic ingredient he puts into it. Any thoughts of what he's doing there on the motorcycle?
Yeah, I'm not sure. I'm not sure what this you're referring to. Steve Ryan. He's famous because he got on 60 Minutes.
Right. Exactly. Yeah.
And we've over the years there have been a number of claims. Water, running internal combustion engines on just water. Mm-hmm. Closed loop systems where that's my only input being claimed. Nearly everyone in the scientific community just agrees that's a fraud.
I know.
Because look what you're trying to overcome.
Oh, sure.
Especially when they say it's just hydrogen, they know not only does it take more energy to dissociate the water to hydrogen than you ever get back, but you're overcoming the high inefficiency of internal combustion engine.
Sure, which means you need an efficiency of at least 4 to 5 to just sort of break even with a smidgen over.
Right. That's why just self-running a genset, an idle, is a grand slam demonstration. You're 5X. Just to factor in all the other losses in the system, just to do that. And, of course, if you want to claim you have a new energy source for mankind, obviously it has to run itself. It's a pretty weak energy source if it can't even run itself, right?
Sure.
Don't bother making announcements if you can't even get it to run itself.
Yep.
The bottom line is, it's a spectacular demonstration. I think within the last month or so, one announcement came out of Pakistan. The reason it made press is because the leaders in Pakistan got excited, says, holy cow, let's support this thing. And the physicists in Pakistan are just shaking their heads. And don't you see that all this violates the laws of thermodynamics?
Right.
And the reporter in Pakistan said, I love this quote, this is Pakistan. You tell me, what law in Pakistan has not been violated?
Love it.
I'll probably put a slide up that says that. I loved it too. And so there you go. Every year or so somebody comes with an announcement, and we have famous names, famous videos of the press releases and things like that, all of which is shrugged and considered impossible. And, of course, the inventors don't really help because all they know, it must be hydrogen because, after all, it burns, came out of electrons, burns, what else could it be? And thus, they don't help matters by saying, I'm making hydrogen and now I can make itself run, right? Because anybody that stayed in late high school chemistry realizes that can't be done.
Right.
And so the explanation doesn't even come close to explaining where this big anomaly is coming from. Definitely a second energy is entering the system. And in this case, if we make these plasmoid-type clusters and we ignite them with high voltage that can come from the spark plug, then we made these plasmoids. And these plasmoids are the thing that moves the cylinders.
So let's look to the future here. Now, we've only got a couple minutes left, Moray, and I want to make sure we get into here. You put together just an absolutely excellent talk as a PowerPoint or in a PDF form. Could you tell people where they might be able to find out where they can get that if they want to find out more about this, and then we'll go back to the discussion? I want to get that.
Sure. Right. All my work on this particular topic, starting, I think, in 2007, all my PowerPoint presentations are available for download on the web. You get to them by Googling 3 words, water, fuel, ZPE. ZPE stands for Zero Point Energy. Mm-hmm. It gets to a site. The PESWiki site is what Sterling Allen made for me after I gave my first presentation in 2007. There's a summary video at the beginning of the site, and under subsequent materials are all my presentations for download. And the 2012 presentation on this topic, cavitating electrolyzers, the key to overunity, is complete, has speaker annotation. So everything I would have said occur if you just mouse over the little orange icon upper left. In order to see that, not all browsers will show that. You just simply download or save it on your local computer and then view it in the Adobe viewer. Then you can read all the speaker annotations and have
I'm
all
doing that as we speak. It works just fine.
Yeah, and so I think I annotated the 2009 as well, the presentation.
Okay, I have the most recent one in front of me. That's good.
Yeah, and the earlier ones I was making comparisons to the PAP engine. I think the analogy is great. I think the same phenomena that moves the cylinder in the PAP engine, plasmoid form, that gets ignited by an abrupt spark. That same phenomenon is happening in these Brown's gas when you use that in the internal combustion engine, especially if you make more of this cluster gas and less hydrogen. And part of the suggestions in the slideshow is to how can we make more cluster gas and not make hydrogen. We don't really want hydrogen because that's a loss anyway.
So where do you see in the last 2 or 3 minutes here of our program, where do you see the major developments going on in the near future, either particular inventors or a particular technology that's going to really bring this to the point where we can absolutely convince those diehard academics that this is real? Any thoughts?
Yeah, I think massive replication. These experiments become so easy to do, and once the inventors share what they discovered on the web with each other, a lot of them are sharing already.
Yes.
Focus on the fact that we don't want hydrogen, we want more of this cluster gas and techniques for making it. Separate out the hydrogen so we can study the residual gas, and you'll see other people doing that. The slideshow references them. Mm-hmm. And massive replication is the key because we have plenty of hobbyists doing it. They'll interest students. Students will interest their professors, and the discovery will be made in a distributed fashion across the planet.
Good. Good. Wow. Any final thoughts? Do you have a website yourself, or do your stuff, or just your books?
Yeah, on this topic, it would be just the water, fuel, ZPE. You'll get to all the information on this topic. The books can be gotten from Adventures Unlimited Press.
Mm-hmm. Excellent.
And that's the game is lots of inventors and hobbyists come on board and just share on the web, share the information, and the discovery will be made as a group. It's kind of neat that we work together. And interestingly enough, when we work in parallel like that, the various trial and error things that are done typically by one guy serially, like Edison, trial and error to make the light bulb,
sure,
can be done in parallel by all the inventors participating worldwide. And the discovery bubbles out really fast, especially if there's sharing of the information.
Mm-hmm. Especially if they let the hydrogen gas diffuse away.
Right. We're interested in that second gas. That is where the big anomaly, that's where those little vortex rings or torus forms are. That's when we ignite them into plasma. So we get the plasmoids, which move the cylinder.
Right. And so in reality, it isn't magic. It isn't impossible. It's just a new and better way of understanding what's happening at the microscopic physical level. And once people get that through their head, they'll realize this is not, quote, impossible, but it's a reality, and that's very, very exciting.
Yeah, that zero-point energy could actually couple it into the system so simply.
Yes, yes. Well, Moray, I think we're out of time here. I appreciate very much your input and your thoughts, and I recommend to the listeners that if you want to find out more, go to that website and pull down that talk that Moray did and read through it. Lots of pictures there. It's very, very instructive. And Moray, of all the people doing this, working in this field, I think you're one of the very few who's actually stepped back and tried to combine experimental results from multiple inventors and engineers and scientists into an overall cohesive, coherent understanding of the phenomena that are going on. And it's going to be people like you who are really going to drive this whole thing forward. And I want to thank you very much, not only from the World Fusion Network and the Orion Project, but also from the world in general, because this energy source may be understood and utilizable in the near future. Thank you.
Hey, you're welcome.
Well, this has been an hour with Dr. Conversations with Dr. Greer. This is Dr. Ted Loder speaking with Moray King, and we want to thank the World Fusion Network for bringing this to you, and we'll probably see you in the World Fusion Network in about 2 weeks. Thank you very much. Goodbye, Moray.
Goodbye.